Imagine stepping into a car in 1963 and hearing a jet engine shriek instead of a V8 rumble. Looking down, you weren't facing a standard dashboard, but a futuristic aircraft cockpit, with a 60,000 RPM tachometer and a pyrometer measuring blistering inlet temperatures. The 1963 Chrysler Turbine featured America's wildest instrument panel, a beautifully engineered control center designed to guide everyday drivers into a radical new aerospace era. To understand why Chrysler created such an unusual layout, one must look closely at the cultural landscape of the early 1960s. America was fully engulfed in the jet age. Commercial aviation was expanding at an unprecedented rate. Military fighter aircraft represented the absolute pinnacle of technological achievement, and the space race was capturing the collective imagination of millions. The future was arriving at a blistering pace, and American car manufacturers eagerly capitalized on this widespread fascination. Up and down Detroit, studios filled showrooms with sweeping tail fence, chrome missile shapes, and pointed nose cones borrowed directly from aerospace blueprints. Yet, for the vast majority of these manufacturers, the connection to aircraft technology was purely cosmetic. Beneath the flashy, rocket-shaped sheet metal lay the exact same internal combustion piston engines that had powered automobiles since the turn of the 20th century. Chrysler, however, wanted to build a vehicle that did not just look like a jet, they wanted to build a vehicle that actually was one. For nearly 2 decades leading up to the 1963 release, a dedicated team of engineers at Chrysler had been quietly experimenting with gas turbine engines. They were convinced that turbine power could eventually displace the traditional reciprocating piston engine entirely. The theoretical advantages were massive and undeniable. A gas turbine engine had roughly 1/5 the moving parts of a standard V8 engine. There were no pistons moving up and down, no complex valve trains to adjust, no distributors to wear out, and no liquid cooling systems to leak. It required no conventional oil changes because the engine oil never came into contact with combustion byproducts. Furthermore, the combustion process was continuous, resulting in an exceptionally smooth power delivery with zero engine vibration. If this technology could be successfully adapted for the stop-and-go realities of everyday driving, Chrysler believed they would fundamentally revolutionize the entire global transportation industry. If they were going to put a miniature jet engine into a production car, the interior needed to do more than just match the exterior styling. It had to retrain the driver's mind to operate a vehicle that functioned on a totally different set of physics. The resulting 1963 Chrysler Turbine Car was the physical manifestation of this grand corporate vision. The vehicle featured a stunning body, hand-built by the legendary Italian design house, Ghia, wrapped in a distinctive metallic hue known as turbine bronze. But while the exterior was undeniably elegant, the real revolution occurred the moment a driver swung open the heavy door and looked inside. The dashboard was dominated by the same rich bronze finish, creating a striking sense of unity that intentionally broke away from the bright, distracting chrome accents and multicolored plastic trim typical of early 1960s American cars. Chrysler opted for a far more sophisticated, industrial look that prioritized function, precision, and clarity. Every single knob, switch, and gauge was meticulously placed to convey a clear message to the occupants. You are no longer operating a regular car. You are commanding a highly advanced machine powered by cutting-edge aerospace technology. The centerpiece of this bizarre interior was the main instrument cluster, situated directly in front of the driver. Rather than a flat panel of gauges, Chrysler designed 3 deeply recessed, independent pods that closely resembled the flight instruments of a contemporary aircraft. The layout was incredibly clean and purposeful, stripping away decorative clutter to ensure that critical engineering data could be read at a single glance. The most striking instrument in this cluster was undoubtedly the in a standard American passenger car of the era, a tachometer was a rare luxury, and those that did possess one generally featured a needle that redlined around 5,000 or 6,000 RPM. The Chrysler Turbine's tachometer, by contrast, featured a dial that went all the way up to an astonishing 60,000 RPM. This was not a stylistic exaggeration. It was a literal reflection of the engine's operation. The turbine idled at a staggering 22,000 RPM, a number so high it would instantly destroy a conventional piston engine. When the driver pressed the accelerator pedal down, the needle would sweep upward into ranges that seemed completely unbelievable to the uninitiated motorist. Directly adjacent to this hyperspinning tachometer sat another highly unusual gauge that highlighted just how mechanically different this vehicle was from anything else on the road. Because the gas turbine engine lacked a radiator, water pump, or traditional liquid coolant, a standard water temperature gauge was completely useless. Instead, drivers were required to monitor the internal temperature of the engine's airflow using a gauge calibrated to measure turbine inlet temperature. This pyrometer featured a scale that climbed up to 1,800 degrees Fahrenheit. Operating the vehicle safely meant keeping a watchful eye on this needle during startup and heavy acceleration. If the engine's internal temperatures climbed too high, there was a very real risk of structural failure or melting the specialized metallurgy of the turbine wheels. For the average American driver used to ignoring their dashboard until a warning light came on. Tracking engine inlet temperatures in degrees Fahrenheit was a profoundly alien experience that required the mindset of a flight engineer. The third main pod in the cluster housed the speedometer, which was paired with an odometer and a fuel gauge. While a fuel gauge sounds ordinary, even this system operated on a different level of utility due to the turbine's unique multi-fuel capabilities. Because the combustion process was continuous and relied on a steady spark plug ignition only during the initial starting sequence, the engine could run smoothly on virtually any liquid that could flow through a fuel line and burn when mixed with compressed air. Throughout its testing history, the Chrysler turbine successfully ran on unleaded gasoline, diesel fuel, kerosene, jet fuel, and JP4. During promotional tours, engineers famously fueled the car with non-traditional liquids like peanut oil, soybean oil, and even a bottle of Mexican tequila to prove its versatility. The fuel gauge on the dashboard, therefore, did not just represent gasoline. It represented a vast, adaptable spectrum of combustible energy, a concept that felt centuries ahead of its time. Beyond the main instrument pods, the rest of the dashboard layout continued the unapologetic aviation theme. Running directly down the center of the cabin, splitting the front bucket seats, was a massive, prominent console made of brushed aluminum. This console was styled to look precisely like the internal compressor shaft of a jet engine, complete with stylized ridges and a metallic industrial texture. Perched directly on top of this central structure was a heavy chrome transmission lever. Rather than utilizing a column shifter or a standard floor stick, Chrysler designers shaped this control mechanism to mimic a pilot's thrust controller or throttle quadrant. Moving the lever forward or backward felt exactly like adjusting the engine output of a commercial airliner, further cementing the psychological connection between the driver and the skies. Even the everyday comfort and convenience controls were reimagined through an aeronautical lens. The heating, ventilation, and air conditioning controls did not use simple slides or cheap plastic dials. Instead, Chrysler utilized a row of high-quality, spring-loaded toggle switches and heavy-duty knobs arranged with a level of mathematical precision that suggested engineering demands had completely superseded aesthetic styling. When a driver wanted to clear the windshield or adjust the cabin temperature, the physical sensation of clicking these switches felt remarkably substantial, akin to a pilot running through a pre-flight checklist. The entire dashboard acted as an educational bridge, intentionally designed to make a radical, potentially intimidating powertrain feel manageable, exciting, and premium to consumers who had never encountered anything like it before. What makes the story of this bizarre dashboard truly remarkable is that it was subjected to the ultimate real-world stress test. Chrysler did not keep these 55 hand-built vehicles locked away in top-secret proving grounds or hidden inside styling studios. Instead, between 1963 and 1964, the corporation launched an unprecedented public evaluation program. Chrysler's public test program placed 55 turbine cars in the hands of 203 ordinary Americans for 3 months, allowing families to use them in everyday life. Drivers quickly discovered the car's unusual behavior, particularly its turbine lag. Unlike a conventional engine, the turbine required a brief moment to spool up from its 22,000 RPM idle, forcing motorists to rely on the dashboard's 60,000 RPM tachometer to anticipate acceleration. Despite the learning curve, participants loved the car's smoothness, lack of vibration, and distinctive jet-like sound. Many believed they were experiencing the future of transportation. However, reality intervened. The turbine's exotic high-temperature alloys made production prohibitively expensive. Fuel economy suffered in city driving, and tightening emissions regulations created additional obstacles. Chrysler ultimately abandoned the project and destroyed most of the fleet. Yet, the turbine car's extraordinary aircraft-inspired dashboard remains an enduring symbol of automotive ambition.